We're going to explore tangent lines and segments. Recall, tangent means a line that intersects a circle at one point and only one point, whereas a secant is a line that intersects a circle at 2 points. We're going to open this applet, so if you have this document open from the agenda, you can click on this. And the first thing that we're going to do is use the orange slider to move point Q, keeping line PR a secant line. So here's the applet, and this is the slider that they were talking about. So we can move the slider so that we're keeping line PR, which is this line here, a secant, meaning it needs to intersect at two different points. So as we move it, you can see the different angle measures here. So here, this angle is 63 degrees. This angle is 117 degrees. So if I wanted to figure out what this angle inside this triangle was, we could take 180 and subtract 117 to get 63 degrees. So this angle is also 63 degrees. If I move it like this, and let's say if we're at 73.71 degrees here, and then if I wanted to see this angle, I would take 106.29 away from 180 again. This angle is also 73.71. And that should make sense because look at the type of triangle that we would always have here. No matter how I move it, as long as we have a secant with line PR, even if I move it all the way over here, this would be a 45-degree angle, this would be a 45-degree angle, now this would be a 90-degree angle. So no matter how I do it, these two angles stay the same, which makes sense because this side and this side of the triangle are both radii of the circle. So that means that the type of triangle that I've always created here is an isosceles triangle because these two sides are always the same. I can't say that it's always acute or always right because in this case I do have an acute triangle, but we showed another example of where we would have a right triangle. So the question here says, what type of triangle is OPQ always going to be? We can say it is always going to be isosceles because two of the sides are radii of the circle. And therefore they are congruent to each other. Drag the slider until the triangle disappears, making line PR a tangent line. When PR is a tangent line, what is true in the diagram? So if we move this, so that line PR here, we want it to become a tangent, meaning it intersects the circle at exactly one point. And here we have that. And what I notice is that this line PR is perpendicular to the radius of the circle. So we've created a 90-degree angle here. So we would say PR is perpendicular to the radius of the circle. And this is actually going to be true of all tangents. No matter what, when you have a circle and you have a line that is, ooh, that's not going to work out, a line that is tangent, so it intersects at one point, it's always going to be perpendicular to a radius of the circle. So this would be a 90-degree angle if this was the radius. So that's always going to be true. And because of that, we can now start to test to determine if a line is actually tangent to the circle. So in each of these, in number 5, we're being asked, is line AC tangent to circle O in each of the following? Explain how you know. So really what we're asking is this angle here a right angle? So we have two angles of the 3 given. So we know that all 3 angles in a triangle should add up to 180. So if I take, 180 and subtract 32 and subtract 58, we do in fact get 90 degrees. So this angle is a right angle. So yes, AC, line AC, is perpendicular to segment OC, which is your radius. So we would say that it is tangent. In this example, if I take 180 and I subtract 51 and then 49, I'm left with 80 degrees, which means this is not a right angle. So no, this is not going to be tangent. And the reason is that, again, line AC is not perpendicular to segment OC. In this situation, we don't have our angles, but we do have a variety of segments labeled here. So I can see that the radius of the circle is 5, segment AC is 11, segment AB is 8, so only from here to here, that kind of periwinkle color. So I know B to O is also 5, since that's also a radius of the circle. So really this entire segment AO is 8 plus 5, or 13 units long. So we can check to see if this is a right triangle by making sure that the side lengths work in the Pythagorean theorem. So we can check if 5 squared plus 11 squared, our two legs, equals the square of the hypotenuse. So we're checking to see if this actually works out. 5 squared is 25, and 11 squared is, 121. Didn't mean to drag that out there. So if I add those together, that's 146. We're checking, does this equal 13 squared, which is 169. So since those are not equal, this is not a right triangle. So we would say that line AC is not tangent, because line AC is not perpendicular to segment OC. We can do the same thing here. Again, our radius is 12, so from O to B, that would be 12 units, which means this entire segment from A to O is 8 plus 12, or 20 units. So we want to check if 12 squared plus 16 squared does in fact equal 20 squared. 12 squared is 144, and 16 squared is 256. And when I add those together, that is 400. And does that equal 20 squared? Well, yes, that's also 400. So they do equal each other, which means that we have a right triangle. So this tells us that yes, AC is a tangent because AC is perpendicular to segment OC. So yes, we have a tangent here. Because tangents and circles build right triangles, we can use all of the skills from our trig unit to solve for missing information, which means that we might be using SOHCAHTOA, or we could be using the Pythagorean theorem, anything that deals with right triangles. So it says, solve for the missing information in each of the following. Assume any lines that appear to be tangent are tangent. So it appears that this is a segment that is tangent to the circle. So we would say that this has to be a right angle. So that means that in this situation, I want to solve for this side. Well, since the radius is 6.6, I know that this length from this point to this point is also 6.6. So we have two sides of the triangle and we're solving for the third. So this is a Pythagorean theorem problem. We do want to know what this entire side is. And if I add 4.4 plus 6.6, that's going to be 11 units. So if I call this side x, we could say that x squared plus 6.6 squared should equal 11 squared. 11 squared I know is 121. 6 squared is 43.56. So we would have x squared plus 43.56. To isolate x squared, we'd take 43.56 away from both sides, which leaves us with 77.44. And when I square root, we can go ahead and just approximate. And actually, this one gives us an exact answer. The square root of 77.44 is exactly 8.8. So this side over here is 8.8 units. Over here, we have this segment appears to be tangent, so this means this is a right angle. So again, I have a Pythagorean theorem problem. Now there's actually two ways to do this. One way is a little bit more challenging than the other. I know that I'm only looking for this length here, and I know that this distance from here to here is 8 units. But instead of trying to think about this length on its own right now, let's focus on the entire side. So let's say I call this entire side of that triangle y. Then we would know that 8 squared plus 15 squared should equal y squared because y is your hypotenuse. So 8 squared is 64 and 15 squared is 225. So if I add those together, that's 289 and that would equal y squared. So if we square root both sides, we would get that y is what, 17 units. That means this entire distance is 17. So if I'm solving for just this distance here, the missing part, let's call that x, well, I know then that 8 plus x should equal that entire 17, so x would equal 9 units. So I would say this is the easier way to do it. The second way will involve using a quadratic equation and needing to solve a quadratic. So something else that you could do here, instead of using that distance of y, again, we know that this from this point to this point is 8 units long, and we could call this length x. Well, that would mean that 8 squared plus 15 squared would equal this entire distance, which is x plus 8, the quantity squared. So again, 64 plus 225, or we could just go ahead and write 289, equals, now when I square x plus 8, this is the same thing as taking x plus 8 times x plus 8, which is x squared plus 16x plus 64. So you can see we have a quadratic here. So to solve a quadratic, one of our options is to get it set equal to 0. So x squared plus 16x, if I do 64 minus 289, that's going to be minus 225. And then I could solve this quadratic. And you could factor it, you could use the quadratic formula, but what you'll end up getting is x equals 9, and then you would also get x equals negative 25. And this would not be a solution that would work in this problem because we can't have a negative length. So you would get x equals 9 by solving that quadratic. The last problem here has us solving for some missing sides, but in this case, we're given another angle here, and that means that we're going to be using SOHCAHTOA. We're going to have some trig functions that we're going to have to solve. So let's find one of these pieces at a time. So if I wanted to find x first, 24 degrees is this angle here, and we have a right triangle because this segment here is tangent to the circle. So we have, if from this 24 degrees, this side is considered the adjacent side, and 39 degrees is the hypotenuse. So adjacent over hypotenuse goes with cosine. So we could say that the cosine of 24 equals the adjacent, which is x, over the hypotenuse, which is 39. So to solve this, it's like a proportion. 1 times x is x, and that equals the other cross product, which is 39 times the cosine of 24. We would want to use our calculators in degree mode. We could type that in, and we would get that x is approximately 35.6 units long. We could do the same idea for solving for y, but from the 24 degrees, this side is the opposite. So we could use the opposite in hypotenuse, which means we could use sine. So we could say the sine of our angle 24 degrees equals opposite y over hypotenuse 39. And again, solve that proportion. 1 times y is y. 39 times the sine of 24 is the other cross product. And if we use our calculator, we would get that y is approximately 15.9 units.